This is the code that ScaffoldHub generates. Package.json is the Monorepo manifest. It holds the scripts you'll use to run, build, test, and deploy the project. Agents.md is the contract for agents. It describes the stack and lays down the rules every agent must follow. The docs folder is the long-form reference. Agents.md points at it whenever a topic needs more depth. We'll dig into each area as we go. The packages folder is where the Monorepo actually lives. Backend is the Hono API server. It owns the database, the business logic, and the background workers. Frontend is the React 19 web app, built with Vite. Mobile is the Expo app for iOS and Android. Upload is a local menu setup for S3 compatible file storage and development. Multi-domain is a local caddy setup that lets you test multi-tenant domains on your machine. Deploy holds the scripts and config for shipping to Vercel and to a virtual machine. We'll open each one in the next parts. Inside the backend package, starting with env. Every environment variable the app uses is declared here as a Zod schema. On boot, the schema parses process.env. If anything required is missing or wrong, the server refuses to start and prints exactly what's broken. Next to it on disk are three .env files. .env holds your local secrets. .env.example is the template you copy from when setting up the project. .env.test is used by the unit test and the end-to-end test runner. Server is the entry point. It reads the port from env, runs a startup check that verifies every translation dictionary is complete, and hands the Hono app to the node server. App builds that Hono app. It wires three global middlewares, a request logger, secure headers, and cores, then mounts every feature under the API path through the API routes module. That's the whole root of the HTTP layer. The real work lives in features. Workers is the entry point for the background worker process. It's what runs when you start the worker script. It boots PigBoss, the Postgres-backed job queue, and registers one handler per queue. Today there are two, one for email and one for notifications. Each handler pulls a job off its queue and runs the matching worker function. It also sets up graceful shutdown. This runs as a separate process from the API server. The API enqueues jobs. This process consumes them. The features folder is where the backend does its work. Every domain lives in its own folder. API routes composes the full API. Each feature exports a router, and this file mounts them all. It's the map of every endpoint. Permissions is the single source of truth for authorization. It declares every action on every resource, defines the admin and member roles, and assigns which actions each role can perform. It also declares storage buckets for file uploads. Every entity you've modeled follows the same pattern. Project is just an example, but they're all built from the same files in the same shape. Project API routes declares the HTTP routes and hands each one to a controller. Project schemas defines the Zod schemas for create, update, filter, and the entity itself, shared between backend and frontend. Project enumerators list the fixed option sets. Project label returns the human readable label for the entity. Project API docs registers the open API paths, so the endpoints show up in the generated docs. Project MCP exposes each controller as an MCP tool for AI assistance. The controllers folder holds one file per endpoint: create, update, find many, autocomplete, archive many, restore many, delete many, and importer. As an example, project create controller shows the shape every controller follows. It exports an OpenAPI root config, an MCP tool descriptor, and the controller function itself. The function calls AuthGuard backend to check the project create permission, parses the body with the Zod schema, runs the Prisma create inside there with RLS wrapper so the organization scope is enforced, writes an audit log, and populates any file download URLs before returning. The test folder holds unit tests, one per controller. For generated entities like project, these files are only skeletons. You fill them in for the scenarios that matter to your app. And the end-to-end folder holds Playwright specs, one per page. To see a real example, look at the organization feature. Organization create controller test uses Vitest with a test Prisma client and mocked better Auth. It covers success cases like creating an organization with an auto-generated slug, plus failure cases that expect the controller to throw. The Prisma folder owns everything about the database. Schema.prisma is the source of truth for the data model. Every table, every relation, every enum lives here. The generated folder holds the Prisma client that's produced from the schema. Index is the entry point for the rest of the backend. It exports two clients: Prisma, the row-level security aware client, and Prisma dangerously bypass row-level security, the escape hatch for system operations like Auth, webhooks, and background jobs. Prisma row-level security is the extension that adds the with row-level security helper. It wraps queries in a transaction and sets a Postgres session variable for the current organization, which the row-level security policies read to enforce tenant isolation. Setup row-level security is the script that applies row-level security policies to every table with an organization ID column. It runs as part of the migrate commands. The rest of the folder holds small helpers, relationship builders, error parsing, and shared Prisma types. The translation folder is how the system stays multilingual. Locales declares the 5 supported languages: English, French, Spanish, German, and Brazilian Portuguese. Each language has its own folder with a full dictionary. Although this folder lives in the backend, the frontend uses it too. It imports the dictionaries and helpers directly through the backend workspace package, so both sides speak the same language from the same source. The rest of the files are small helpers that load the right dictionary, format translated strings, resolve the locale, and translate enumerators and dates. The shared folder holds the utilities every feature reuses. Controller holds the per request context and the success and error response helpers. App context is that per request context. It's built at the top of every request, resolves the locale and dictionary from the accept language header, then runs the session or API key middleware to attach the current user, organization, member, subscription, and API key. Every controller reads from it. Errors holds the typed error classes. Generic errors are never thrown. Schemas holds the reusable Zod schemas for numbers, dates, booleans, UUIDs, ordering, and importers. Lib holds small single-purpose helpers. Jobs holds the pgboss setup and the job processor used in inline and cron modes. Email holds the email queue and worker. Open API holds the helper that turns each controller's root config into an Open API path. Inside the frontend package, index.html is the shell Vite serves. It has a single div with ID root. Main is the bootstrap. It creates the TanStack query client, kicks off the auth store init so the user, organization, config, and dictionary are loaded up front, then mounts app into root inside the query provider. App wires the router, the theme provider, and the toaster. That's the whole top of the tree. Vite config is the built-in dev server config with the path alias and the React plugin. Index.css holds Tailwind and the theme tokens. Router mounts every feature's router under a root, split into public and authenticated trees. Auth store is the Zustand store for user, organization, member, subscription, locale, theme, dictionary, and config. Persists to local storage. Init hydrates it on boot. Has permission checks, role permissions. Auth router declares sign in, sign up, password reset, email verify, invitation, onboarding, and the authenticated parent root every protected feature hangs off of. AuthGuard frontend is the function every protected root calls in before load. Past the required permissions, it checks the current user and member and redirects on failure. Auth client is the better auth client. Root layout is the outer shell the root renders. App layout is the authenticated shell, with the sidebar on one side and the main content on the other. App sidebar is the container. App menu renders the list of feature entries inside it. Menus declares every sidebar entry, its label, icon, path, and required permission. Feature icons maps each feature to its icon. These two together drive what the signed-in user sees on the left. The features folder is where the frontend does its work. Every domain lives in its own folder, mirroring the backend. Every entity feature on the frontend follows the same pattern. Project is just an example. Project router declares the routes. Each one runs AuthGuard frontend with the matching permission in before load, then lazy loads its page so the bundle splits per route. The pages folder has one file per route. The list page is a data table. The new and edit pages mount project form. The view page is read only. The importer page mounts the shared importer with a project-specific schema. The components folder has everything the pages compose. Project form is the create and edit form. Project form sheet is the same form inside a side sheet for inline creation from other entities. Project list filter is the filter panel for the list page. Project list actions and project actions are the bulk and row toolbars. The shared lib folder holds the single-purpose helpers every feature reuses. API client and query client are the two clients every feature talks to. The rest are small helpers: CSV export and import, URL and object helpers for filters, dictionary and ZOD error formatting, etc. The upload package is a local Minio container, the S3 stand-in for development. Docker Compose spins it up. One Minio service plus a setup step that creates the two buckets, public and private. Public is anonymous read, private is signed URLs only. The backend reads the S3 env vars the same way in dev and prod, so swapping to AWS, R2, Backblaze, or Spaces is just an env change. The console on port 9001 is there when you want to browse buckets and files by hand. The multi-domain package is a caddy reverse proxy, used only when running the app in subdomain mode. Docker Compose brings caddy up, and the caddy file routes project.localhost and any wildcard subdomain of it, sending the API prefix to the backend and everything else to the frontend. The wildcard is the point. It lets you hit any tenant subdomain locally and have it resolve without touching your host file. A one-time step trusts caddy's local root cert, so HTTPS just works. The mobile package is the Expo app, one codebase for iOS and Android. App is a full-screen web view pointing at the web app, localhost in development, and the production URL in a release build. The web app does the real work, the shell just hosts it. A small bridge lets the two sides talk. The native shell exposes flags and a push token request on the window object. The web side calls in after sign-in, and the native side posts the Expo push token back. Push notifications ride on Expo. Firebase credentials live in the certificates folder. EAS handles builds and store submits. The deploy package holds two shipping paths, Vercel and a virtual machine. The Vercel folder is a drop-in. Copying vercel.json and the API entry to the root wires the backend as a single serverless function and the frontend as a static build. Env vars live in the Vercel dashboard. The VM folder is Ansible. Roles provision Postgres, Redis, Caddy, Minio, and Node. Then the app role lays down backend, frontend, and worker as system services. Deploy gets its own video later. In the next videos, we'll get the development environment up and running and deploy the app. See you there.